Hi, welcome back to my class in Algebra. For today, we will take up linear equations in one variable. In particular, we will study how to solve linear equations in one variable. For those of you who are interested in the graphs of linear equations in one variable, either in variable x or in variable y, you may see my videos in analytic geometry for lessons in linear equations in one variable and linear equations in two variables in different forms, including the general form or standard form, the two-point form, the slope point form, the slope-intercept form, and the intercept form. But for our lesson in algebra, we will solve linear equations in one variable, and we will sketch the graph of these linear equations in one variable using their solutions. And in solving linear equations in one variable, we apply properties of equalities, including the addition property that says adding the same constant to both sides of an equation maintains the equality of the equation. The subtraction property of equality that says subtracting the same constant from both sides of an equation also maintains the equality of the equation. And the multiplication property of equality says multiplying both sides of an equation by the same constant maintains the equality of the equation. Now we have some examples of linear equations in one variable. Number 1, x plus 5 equals 7. This is a linear equation in one variable because there is only one variable x that you can see in this linear equation. And the exponent of x, if you will write the exponent of x, the exponent of x is 1. But if the exponent is 1, it is a convention that we do not write anymore the exponent 1. So instead of writing x to the power 1, we simply write x. And the exponent of x here is 1. In a linear equation, the highest exponent of any variable that appears in the equation is 1. Again, in linear equation, the exponent of any variable that appears in the linear equation is 1. Or the highest exponent of any variable that appears in linear equation is 1. So x plus 5 equals 7 is a linear equation in one variable x because there is only one variable x and the exponent of x is 1. Number 2, we have 3 over x plus 2 over 5 equals 1 over 3x minus 1 over 2. This is also a linear equation in one variable x because you can see there is only one variable in this linear equation in number 2 and the exponent of x is 1. In the first term, we have 3 over x, the exponent of x is 1. This is a constant term. At the right hand side, we have 1 over 3x in the first term. The exponent of x is 1. And negative 1/2 is a constant. So number 2 is a linear equation in one variable x. Number 2, we have 5 minus 7 times quantity 3 minus 2y equals 15y minus 14. This equation is also linear in one variable. The variable is y. And it is linear because the highest exponent of y is 1. Number 4 is another example of linear equation in one variable. And the variable is h. It is linear equation because the highest exponent of h is 1. The exponent of h here is 1. The exponent of h here is 1. The highest exponent of h in this equation is 1. So this equation is a linear equation in one variable h. We start by solving the linear equation in number 1. Now, in solving a linear equation in one variable, only the variable should be at one side of the equation, and the coefficient of that variable should be 1. Again, in solving a linear equation, only the variable should be found at one side of the equation, and the coefficient of that variable, linear variable, should be 1. And all the constant terms should be found at the other side of the equation. But at the left hand side, x is not the only term at the left hand side. There is plus 5, a constant at the left hand side. And we have to bring this positive 5 to the right hand side. The correct process to bring positive 5 to remove positive 5 from the left hand side is to subtract 5 from the left and to subtract 5 from the right. Let's do that. X plus 5 minus 5 equals 7 minus 5. We subtract 5 from the left side of the equation and from the right side of the equation, because the subtraction property of equality says that if we subtract the same constant from both sides of the equation, the equality remains true. And so we simplify. 5 minus 5 is 0. X plus 0 is x. And 7 minus 5 is 2. This is the solution of the linear equation x plus 5 equals 7. Now you find that x is the only variable at one side of the equation, and the coefficient of x is 1. If the numerical coefficient is not specified as in x, it's understood that its numerical coefficient is 1. So this is the solution of this linear equation x plus 5 equals 7. And to check if this is correct, you simply substitute or replace x with 2. And the sum of 2 plus 5 should be 7. And by inspection, it's easy to see that if you substitute the value of x equals 2 into this linear equation, you get 2 plus 5 is equal to 7. So this is correct. Now, other people, when solving linear equation, they make use of what is known as transposition. And this method of transposition will give you the same solution. In transposition, instead of subtracting 5 from both sides of the equation, in transposition, they bring the constant term to the other side of the equation, and they take the opposite sign of the constant term. And they call that process transposition. As in, we want to remove positive 5 from the left-hand side, so we transpose positive 5 to the right-hand side. But when we transpose, we take the opposite side of 5. We do that if we transpose 5 to the right-hand side. At the right-hand side, we have 7. When you transpose a constant to the other side of the equation, always take the opposite sign of that constant. The sign of this constant is positive. When you transpose it to the right, it becomes negative 5. And because we have transposed the constant positive 5 to the right-hand side of the equation, only the variable x is left at the left-hand side of the equation. Now simplifying, 7 minus 5 is 2. Hence x equals 2. As I said earlier, you obtain the same solution if you use the process of transposition instead of using the property of equality. Now, most people prefer to use transposition because it saves them time and they get the same solution. Now, we solve number 2. It's a linear equation in x and we solve for the value of x. This is a linear equation in one variable x, but the left-hand side and the right-hand side, the terms at the left-hand side and the terms at the right-hand side are rational expressions and fractions. And in solving linear equations in one variable that involve rational expressions and fractions, we have to remove the denominators. And we do that by multiplying both sides of the equation. Now we are using multiplication property of equality. We multiply both sides of the equation by what we call LCD. And we multiply both sides of the equation by LCD to remove the denominators. LCD stands for lowest common denominator. Other people, they call it least common denominator. And we start with the numerical coefficients and the constants in the denominators. In the first term, the numerical coefficient of x is 1. In the second term, the denominator is a constant 5. At the right-hand side, first term, the numerical coefficient of x is 3. And in the second term, at the right-hand side, the denominator is 2. Again, the numerical coefficient of x here is 1. The denominator of the second term is a constant 5. And the numerical coefficient of x in the first term of the right-hand side is 3. And the denominator of the constant term at the right-hand side is 2. The LCD of these numbers is the smallest or the lowest or the least number that can be divided by all these numbers. And the smallest number that can be divided by 1, by 5, by 3, and by 2. And if you know well your multiplication table, it's easy for you. It will be easy for you to think of that smallest number that can be divided by 1, by 5, by 3, by 2. Now, for instance, you thought about 10 as the LCD. You check. 10 can be divided by 1, by 5, by 2. But 10 cannot be divided by 3. So 10 cannot be the LCD. Suppose you thought about 6. 6 can be divided by 3 and 2, but not by 5. So you think of the smallest number that can be divided by all these numbers by 1, 5, 3, and 2. And that number is 30. 30 can be divided by 1. 30 can be divided by 5. 30 can be divided by 3. And 30 can be divided by 2. 15 cannot be the LCD because 15 can be divided by 1, by 5, and 3, but 15 is not exactly divisible by 2. You cannot divide 15 by 2. So 30 is the smallest number. Now, the denominators are not all constants. Two denominators, x and 3x, are monomials or algebraic expressions. For the LCD of these denominators, you take all the variables that appear in the denominator. And there is only one variable that appears in the denominators. And that variable is x, and multiply that by 30. Now suppose x appears in this term with exponent of 2. Again, to get the LCD of denominators that contain algebraic expressions, you start with the numerical coefficients and the constants in the denominators, and you take the smallest number that can be divided by these numerical coefficients of the variables and the constants. And you take all the variables that appear in the denominator. In this example, there is only one variable that appears in the denominator, and that variable is x. Now suppose the denominator of 3 is not x but x squared. For the LCD, you take the highest exponent of x. Here the exponent of x is 2, here the exponent of x is 1. And between 2 and 1, the higher exponent is 2. So you write here, x squared multiplied by 30. If the variable x appears in the denominators more than once and with different exponents, you take the highest exponent of the variable x, as in this example, x squared and x, and the higher exponent between 2 and 1 is 2. Now, why did we take x squared? Because x squared can be divided by x squared. X squared can be divided by x. If you simply take x can be divided, x in the LCD can be divided by x, but x in the LCD cannot be divided by, exactly divided by x squared. So we take x squared for the LCD and multiply it by 30, the LCD of the constants and the numerical coefficients. Now, we go back to the original equation. This is x. Now, supposing there is another variable in the denominator. Suppose instead of 5, you have 5y. As I said earlier, when you get the LCD of denominators containing algebraic expressions, take all the variables that appear in the denominator. And if that variable appears with different exponents, take the highest exponent of that variable. In this example, x appears in the denominators, in two denominators. So we take x, and the highest exponent of x is 1. So we take x. For the LCD, multiplied by 30. And there is another variable y in the denominators, just supposing that there is y in the denominator of the second term, 5y. So we also take y for the LCD and multiply that by 30x. And this is the LCD, 30x can be divided by x, by 5y, by 3x, and by 2. This monomial can be exactly divided by x, by 5y, by 3x, and 2. Now we go back to the original linear equation in x. After you obtain the LCD, you now multiply the left-hand side by the LCD. 30x multiply by the left-hand side 3 over x plus 2 over 5 equals the right-hand side of the equation also multiply by the LCD 30x multiply by the right-hand side 1 over 3x minus 1/2. And we remove the grouping symbols by applying the multiplication property, the property of multiplication over addition. We multiply each term of this binomial. Now we remove the grouping symbols by applying the multiplication property of multiplication over addition. We multiply each term of this binomial by 30x. If you multiply 30x by 3 over x, x and x will cancel out because x over x is 1. So we multiply 30x by 3 over x and x will cancel out, and you get 30 multiplied by 3 is 90. You also multiply 30x by 2 over 5. Now 30 divided by 5 is 6. Or 30x divided by 5 is 6x. And we multiply 6x by 2. And 6 multiplied by 2 is 12x. At the right-hand side, we also distribute 30x to each term of this binomial. We multiply 30x by 1 over 3x. Again, x over x is 1, or x will cancel out. And 30 multiplied by 1 is 30, divided by 3 is 10. We also multiply 30x by negative 1/2, and this is positive, multiplied by negative is negative. And 30 divided by 2 is 15, multiplied by x is 15x, multiplied by 1 is 15x. So we have successfully removed the denominators, and we can now solve for x from this equation. And to solve for x from this equation, all the terms with the variable x must be at one side of the equation, and all the constant terms must be at the other side of the equation. Now to bring negative 15 to the left-hand side, either you add 15x to both sides of the equation, plus 15x here, plus 15x here. Or you make use of transposition, you transpose negative 15 to the left side, and you take the opposite sign of negative 15, and it becomes plus 15. And to bring 90, the constant 90, to the right-hand side, you either make use of subtraction property of equality, subtract 90 from the left, or subtract 90 from the right. or you transpose 90 to the right hand side and you take the opposite sign of 90. From positive, it becomes negative 90 or minus 90 after transposition. Now we make use of transposition to simplify the process. We transpose negative 15x to the left hand side. At the left hand side, we have 12x. We transpose negative 15x to the left hand side and we take the opposite sign of negative 15x. It becomes positive plus 15x after transposition. At the right hand side, we bring all the constants to the right hand side of the equation. At the right, we have 10. And we transpose positive 90 to the right hand side. We take the opposite sign of positive 90, it becomes minus 90. Now after the transpositions, you combine the terms. These are now like terms at the left hand side. 12x plus 15x equals 27x. Equals 10 minus 90 is minus 80. And in the final solution, the coefficient of x should be positive 1. So we divide, to remove 27 here, in the coefficient of x, we divide both sides by 27. The left hand side, we divide by 27. And the right hand side, we divide by 27. And 27 over 27 is 1, or 27 over 27 will cancel out from the left hand side. And you get x equals negative the solution x equals negative 80 over 27. If you can reduce this 80 over 27 to lowest terms, you do that. But this cannot be reduced further to lowest terms. But it can be converted to mixed fraction because this is a negative improper fraction where the numerator is greater than the denominator. Again, to check if this value of x equals negative 80 over 27 is a solution of the second linear equation in one variable x. You replace x with negative 80 over 27 at the left hand side, and also at the right hand side you replace x with negative 80 over 27. And you simplify the left hand side and simplify the right hand side. And you check if the equality will still hold true. We will do that now. Now check if our solution for the second linear equation x equals negative 80 over 27 is correct. By substituting this value of x in this linear equation, we have 3 over x but x equals negative 80 over 27 plus 2 over 5. We want to check if this sum is equal to, so initially we write a question mark above the equal sign because we are still checking if this sum will be equal to 1 over 3x. but x equals negative 80 over 27. Since this is negative, we write that in open close parentheses. Minus 1/2. Now, this is positive, divided by negative equals negative. And to simplify this fraction, we multiply 3 by the reciprocal of 80 over 27. Three multiplied by the reciprocal of 80 over 27, which is 27 over 80. Plus 2 over 5. And we want to check if this sum is equal to the difference at the right hand side. Now, 3 and 27 can be, 3 over 27 can be simplified by dividing 3 and 27 by 3. 3 divided by 3 is 1. And 27 divided by 3 is 9. And to simplify this fraction, we multiply 1 by the reciprocal of negative 80 over 9. This positive 1 divided by negative is negative. Negative 1, we multiply by the reciprocal of 80 over 9, which is 9 over 80. Minus 1/2. Now, 3 and 80 cannot be simplified further because 80 is not divisible by 3. So, we multiply 3, negative 3 by 27, and negative multiplied by positive is negative. 3 multiplied by 27 is 81 over 80. Plus 2 over 5. We want to check if this sum is equal to the quantity at the right hand side. Negative 1 multiplied by 9 is negative 9. Divide by 80 minus 1/2. Now, to combine these fractions, we take the LCD of 80 and 5. And the LCD is the smallest number that can be divided by 80, and 5 is 80. We check 80 is divisible by 5. 8 divided by 5 is 1. 1 multiplied by 5 is 5. 8 minus 5 is 3. And we bring down 0. And 30 divided by 5 is 6. So 80 is divisible by, exactly divisible by 5. And it's divisible by 80. To find the numerator here, we divide the LCD by each denominator and multiply the quotient by the numerator. We have 80 divided by 80 is 1. Multiply by negative 81 is negative 81. Plus 80 divided by 5 is 16, multiplied by 2 is 32. We want to check if this quantity is equal to the right hand side. Now to combine these two fractions at the right hand side, we get again the LCD of 80 and 2. The smallest number that can be divided by 80 and 2 is 80. And to find the numerator, we divide the LCD by each denominator and multiply the quotient by the numerator. 80 divided by 80 is 1, multiplied by negative 9 is negative 9. 80 divided by 2 is 40, multiplied by negative 1 is negative 40. Now, in the numerator, we add negative 81 plus 32. We have 81, 32. 11 minus 2 is 9. And 7 minus 3 is 4. And the sign of the bigger number is negative. Hence, negative 81 plus 32 is negative 49. Negative 49 over 80. And this is equal to minus 9 minus 40 is negative 49 over 80. Hence, the equality is satisfied by this value of x equals negative 80 over 27 when substituted into this linear equation in x. Therefore, the solution, this value of x equals negative 80 over 27 is correct. Now we will solve the third linear equation in the variable y. If you have a grouping symbols in the given equation, such as in this linear equation in number 3, we have these grouping symbols, a pair of parentheses. The first step is remove the grouping symbols. So to remove the grouping symbols here, we apply multiplication property of multiplication over addition or subtraction. Do not get the difference 5 minus 7 and multiply the result. Multiply 3 minus 2y by the result. You would get a wrong solution. If you find grouping symbols in a given equation, the first step is remove first the grouping symbols. Such as in this case, we remove the grouping symbols by multiplying each term of this binomial by negative 7. And that's the multiplication, property of multiplication over addition or subtraction. We have 5. Distribute negative 7 multiplied by 3 is negative 21. Now multiply negative 7 by negative 2y. Negative times negative is positive. And 7 multiplied by 2 is 14y. 7 multiplied by 2y is 14y. At the right hand side, we still have the same terms, 15y minus 14. Now, the next step is to collect all the terms with the variable y in one side of the equation and all the constant terms to the other side of the equation. And you have two choices here. Either you bring 15y to the left hand side or you bring 14y to the right hand side. If you bring 15y to the left hand side by transposition, and you combine it with 14y, you will get a negative coefficient of y. But if you bring 14y to the right hand side by transposition, you will get a positive coefficient for y. So we will transpose 14y to the right hand side and negative 14 to the left hand side. And we will do the transposition method. On the right hand side, we have 15y. Transpose 14y to the right hand side, take the opposite sign of positive 14, it becomes minus 14y after transposition. Hence, at the right hand side, we have 15y minus 14y equals, at the other side of the equation, we have 5 minus 21. You may already get the difference of 5 minus 21, and you get negative 16. Negative 16 is 5 minus 21. And we transpose negative 14 to the left hand side. We take the opposite sign of negative 14, it becomes positive 14 after transposition to the left hand side. Now 15y, combine these similar terms or like terms, 15y minus 14y. 15 minus 14 is 1, and that's positive. And the common literal coefficient is y, or 1y, or we simply write y equals negative 16 plus 14 is negative 2. Again, we check if this value of y, for our solution, y equals negative 2, is a solution, is a correct solution of this linear equation. 5 minus 7 times quantity 3 minus 2y equals 15y minus 14. By substituting the value of y into this equation, we have 5 minus 7 times quantity 3 minus 2 times y negative 2. Equals 15 minus y is negative 2. At the right hand side, we have 15 multiplied by y. Y is negative 2 minus 14. Now we are just checking if the quantity at the left equals the quantity at the right. So initially we put a question mark above the equality sign, and we simplify this. Again, remove the grouping symbols, and you start from the innermost grouping symbols. Multiply negative 2 by 2, that's positive 4. We have 5 minus 7 times quantity 3, and negative 2 times negative 2 is positive 4. At the right hand side, we have 15 times negative 2, positive 15 times negative 2 is negative 30. Minus 14. And we still have grouping symbols at the left hand side. So we perform the operations inside the grouping symbols. We have 3 plus 4 is 7. We have 5 minus 7 times 3 plus 4 is 7 equals negative 30 times negative 30 minus 14 is negative 44. We have 5. We multiply negative 7 times positive 7 is negative 49. Finally, 5 minus 49 is negative 44. And that is equal to the right hand side negative 44. Thus we conclude that our solution y equals negative 2 is correct because it satisfies this linear equation when the value of y is substituted into this linear equation. And the equation is both sides of the equation are equal, or the equation is satisfied. Now we solve the last linear equation, the linear equation in H. Again, if you have a rational expressions in the given equation, the first step is to remove the denominators by getting the LCD. And for this linear equation in number 4, the denominators are constants. And so to get the LCD of 2 and 3, you think of the smallest number that can be divided by 3 and 2. And that smallest number is 6. Now, 12 can be divided by 3 and 2. 12 can be divided by 3, 12 can be divided by 2. And you can use 12 to remove the denominators. And also 18 can be divided by 3, 18 can be divided by 2, and you can use 18 to remove the denominators 2 and 3. But to make the solution easier, to make the process easier, we take the lowest common denominator. And that lowest common denominator is 6. The smallest number that can be divided by the denominators 3 and 2 is 6. Now we now combine the left hand side using our LCD. You can do it this way, or you can multiply both sides by the LCD. Let's do that instead. After you get the lowest common denominator, multiply the left hand side by the LCD and multiply the right hand side by the LCD as we did in example 2. So the LCD is 6. Multiply that by the left hand side, h plus 3 over 2. Minus 2h minus 1 over 3 equals the right hand side also multiplied by the LCD 6 multiplied by 1. And to remove the grouping symbols, we use the multiplication, the property of multiplication over addition or subtraction, which means we multiply each term of this binomial by 6. And if you multiply 6 if you multiply 6 by h plus 3 over 2, you can see 6 is divisible by 2. And 6 divided by 2 is 3. 3 multiplied by h plus 3. Minus, we multiply also 6 by 2h minus 1 over 3. And you can see 6 is divisible by 3. We can divide 6 by 3, and 6 divided by 3 is 2. Times negative here, negative 2. Multiplied by 2h minus 1. Equals 6. Now we have removed the denominators 2 and 3, but we now have grouping symbols. But they can be easily removed by using property of multiplication over addition or subtraction. That means we multiply each term of this binomial by 3. 3 multiplied by h is 3h. 3 multiplied by 3 is 9. We also distribute negative 2 to each term of this binomial. We have negative 2 times positive 2h is negative 4h. Negative times negative is positive. And 2 multiplied by 1 is 2. Equals 6. Again, all the terms with the variable h should be at the left-hand side or one side of the equation. And all the constants should be at the other side of the equation. We have 3h minus 4h. We can now combine 3h minus 4h. They are like terms or similar terms. 3 minus 4 is negative 1. And the common literal coefficient is h. Again, 3h minus 4h is negative 1h or simply negative h. Equals 6. And we transpose 9 and 2 to the right-hand side. We take the opposite sign of 9 and 2. Positive 9 transposed to the right-hand side becomes negative 9. And positive 2 transposed to the right-hand side becomes negative 2. And we have negative h equals 6 minus 9 is negative 3, minus 2 is negative 5. Again, in the final solution, the coefficient of the variable should be positive 1. But here the coefficient is negative. So to make this positive h, we apply the multiplication property of equality. We multiply both sides of this equation by negative 1 to make the coefficient of h positive 1. The left-hand side, negative h, we multiply by negative 1. And negative 5 at the right-hand side, we multiply also by the same number, negative 1. And we have negative 1 times negative h is positive h. And negative 5 times negative 1 is positive 5. And this is our solution for this linear equation. H plus 3 over 2 minus 2h minus 1 over 3 equals 1. and we check if this value of h will satisfy this equation. If this value of h satisfies this equation, then our solution h equals 5 is correct. We now check if our solution h equals 5 is a correct solution of this linear equation h plus 3 over 2 minus 2h minus 1 over 3 equals 1. By substituting the value of h equals 5 into this equation. We replace h with 5, we get 5 plus 3 over 2 minus 2, replace h with 5, we have minus 2 multiplied by 5 minus 1, which we want to check if this quantity when simplified is equal to 1. Hence, initially we write a question mark above the equal sign. And we have 5 plus 3 equals 8 over 2 minus 2 multiplied by 5 is 10 minus 1. Divide by 3. We want to check if the left hand side is equal to 1. 8 divided by 2 is 4 minus 10 minus 1 is 9 over 3. We want to check if this difference is equal to 1. We have 4 minus 9 divided by 3 is 3. Want to check if this difference is 1. And 4 minus 3 is 1. And it's equal to the right hand side 1. So we put a check above the equal sign because the left and the right quantities are equal. Thus, this value of h equals 5 is a correct solution of this linear equation in one variable h. For your practice, please try the following exercises. Solve the following linear equations in one variable. In number 1, you have 2y plus 3 equals y plus 4. This is a linear equation in one variable y. In number 2, you are given 5 over y minus 1 half equals 2 pips plus 1 over 4y. This is a linear equation in one variable y. The first step is to remove the denominators. You determine the LCD or the lowest common denominator of these denominators y, 2, 5, and 4 over y. And multiply both sides by that LCD. In number 3, you have a linear equation in variable x. 3x equals 5 minus 8 times quantity 2x minus 1. Again, the first step, if you have grouping symbols in the given equation, remove first the grouping symbols by using the property of multiplication over addition or subtraction. In the last equation, you have linear equation in variable m. Again, remove first the denominators 3, 4, and 2 by using LCD, the lowest common denominator or the lowest number that can be divided by 3, 4, and 2. And multiply the left hand side by that LCD and the right hand side by that LCD. For you to check your answers, I give you the answers. For number 1, y equals 1. For number 2, y equals 95 over 18. For number 3, x equals 13 over 19. And for number 4, m equals negative 1. But you also try to check if these solutions are correct by substituting the value of the variables in the given equation. And that completes our lesson for today. Linear equations in one variable. If you have question about the lesson today, you ask your question in the comments below. And don't forget to subscribe to my YouTube channel, Art Kalisan. the channel of learning and leisure. And ask your friends and your classmates to also subscribe to my YouTube channel, Art Kalison, so they may also learn as well. Thank you for joining me in my class today.